This is just a short presentation. It could even be open for people to contribute on something I encountered at work that was interesting to me, and this is kind of an experiment to see if it's interesting to you. So, yes, it's called the case of the mysterious flapping IDs. This is Hitchcock's The Birds. Wasn't as scary as The Birds. So essentially, I am leading a project where I'm implementing basically sort of like a Google Analytics token for my application. We want to know how users are using our website. And we want to know specifically, it's a website that hosts educational content. People watch videos and take tests or assignments. And we basically want to capture, so they'll like use our site and then they'll like walk away, eat lunch or whatever and come back. And we want to basically track like a distinct session in which they're like actively browsing, and what is happening when they're doing that. So we come up with this idea of a browsing session. This is, by the way, both a mobile website, mobile app, and a website. So the browsing session represents the time the user is active on the application. And we set it or reset it in three cases. So we set it when the user first lands on the site or opens the mobile app via this browsing session ID cookie in Fastly, our CDN. So any kind of hit to open the website, the first thing it goes through is Fastly, the CDN. So that's where we set our cookies, including our authentication cookies. So then if we notice they've been inactive for 30 minutes, we decide, okay, they're no longer browsing. So we reset the cookie. And then we also reset it when they log out. So we assume, like, what if some user is sharing a computer with their younger brother, like they log in, they do a bunch of activity, and then, their younger brother wants to get on the site, so they log out. So while that is like a contiguous amount of activity on the site, it's two different users. A complication, I guess, to this system as well is a user can use the site and not be logged in, but have a browsing session. So you could have two different people using the site, not logged in. We can't tell that they're different users, so we just assume it's the same user in the same browsing session. But, if you guys have worked in analytics or with analytics, the data, it's got caveats. This is what we've got. So this is the system. And also, you should know that the CADE is the user's ID. User activity is associated with the CADE when the user logs in, but also if a user doesn't log in and they do some learning activity, we give them like a temporary CADE, which when they log in, we replace with their real CADE. That's a little more detail maybe than you need. So this is what I'm working with. I'm excited. I learn Rust. I update Fastly. I create the cookie. And then I notice, it looks like there is a situation. Hopefully you can tell what's happening. So if you kind of remember the rules of a browsing session ID that I explained, in this far right column here is a browsing session. This is the user's ID, the CADE. And then these are basically the endpoints the user is hitting and a time. So I just gave you right to left. But yeah, left to right time, endpoints, ID, and browsing session. And so I'm browsing around on the website and I decide I want to look in our Fastly logs for my IP address and just verify that the behavior is happening as I expect. I'm logged in at this point in the first log. And then I see, okay, yeah, I got a browsing session ID. And then wait, what? Why in this yellow line is it changing? What's going on in this green log? And then I notice, okay, so I'm logged in in the blue logs, and then on the white logs I log out, which should clear the cookie and reset it. And it does in this first log. You see the browsing session _FE, the second orange log. But then in the yellow log, there's a new one, and then we're back to the old one again. And then, and then we're back to the new one in this green log. But there are also other cases where I notice in the logs, and I'm able to replicate this in the app where when I log out, it never resets the cookie. Or when I log in, basically, it toggles between a bunch of different IDs. So that's the bug. I first I think I first noticed it when multiple users logged in consecutively on the same device and shared a browsing session ID. I was doing some queries and I was like, that's weird. And then looking at the Fastly logs, I noticed like when a user is on the mobile site, there are a ton of different requests, and you see this kind of toggling back and forth that you see here between browsing session IDs when it is initially cleared. And I also saw in some cases, there wasn't a reset of the browsing session ID when a user logged out. I also was able to replicate this in looking at the cookies in the DevTools over here. So I was like, oh God, this isn't going well. So how does this system actually work, you may ask? Here's a diagram. Basically, the client is coming in with like some some existing browsing session cookie. This isn't the initial request, but a subsequent request. So Fastly doesn't reset it. Fastly doesn't reset it. But in this third request, basically, yeah, so Fastly doesn't reset it. And then the second request, the user logs out, and so the user service responds back to Fastly with a logout request to clear the cookie, and then it clears the cookie. So you have like the client interacting with Fastly, which sends the request to the backend, which sends things back to the client. Fastly is resetting things in the header, or if the request expires, or if the client tells Fastly to expire the request, it's resetting the cookie to blank. So you can kind of see what's going on here with these requests. There's not a queue, basically, or an order with which Fastly is dealing with the request, and sometimes the backend is responding faster than others, and you have a case of the race condition. What I do is I guess I stress out about it, and then I come up with, this is a solution that I came up with, where I don't introduce anything other than an extra cookie. So, right, so we know that there's a problem establishing a new browsing session or clearing an old one. So the downside of my solution is that it makes the code more complicated. The Fastly code now has is a lot more complicated than the initial spec, but so I decoupled the browsing session ID cookie ID and its expiration into two different cookies. And so when Fastly so when the cookie expires after 30 minutes, we increment it, taking the initial cookie into the increment. So even if like we're re-incrementing that logic in Fastly, it arrives at the same result, so it doesn't overwrite the cookie. And then also that way we're not resetting the cookie on every request basically, or rechecking the cookie, but we're like only doing that on logout or expiration. Here are I guess, the most simple situations. So the first case, when a user first interacts with the application, the browser won't already have a browsing session or an expiration cookie. And when they last interacted with the application less than 30 minutes ago, we don't want to reset the browsing session ID, the expiration cookie. They'll have both cookies. But then case 3, if they haven't interacted with the application for 30 minutes, then their browser will have cleared the expiration cookie, and then Fastly can subsequently see there's no expiration cookie and then reset the ID. Or yeah, case 4, when they log out, then the backend expires the cookie which is cleared by the browser. So here's a diagram that I made in order to solve the solution. So this is the first activity on the site. There are no cookies. Fastly creates this header, passes to the backend, and then it attaches the 2 cookies. So there's an expiry cookie, but also the ID cookie does expire, and that's just because we can't have a cookie that never expires. We picked now, like from the current time to 24 hours as the expiration, because we can't imagine a person continuously active on the site without a single 30-minute break for 24 hours. That would be really difficult to imagine, and that person should seek medical help. The cases are hopefully going to be few and far between. So then it sets the cookie, both the ID cookie and the expiry cookie. So then there is like subsequent activity after that, and we can see that um, it sees that there's an expiry cookie, so it doesn't do anything. It resets the expiry cookie only. So we have that mechanism by which we can extend the 30-minute expiry. So every subsequent request doesn't extend the ID cookie, but it does extend the expiry cookie. Here's the expired case. So in the expired case, the browser automatically clears the expiry cookie. And then Fastly notices there's no expiry cookie, increments this, the browsing session ID in the header, sends a request to the backend. Backend sends a response to Fastly. Fastly adds the cookie, the ID cookie, and the new ID cookie, and an expiry cookie on the response, resets it here. And then finally, there's the logout case. Fastly doesn't do anything, but the backend tells Fastly, oh, log out, you got to reset the cookie. It sends a blank cookie, and then Fastly sets it to a completely new one and updates the expiry. So this is just for the concurrent requests, but the harder case is for the synchronous requests. So there's the same kind of version of what you saw before. So a user logs out and a response from the backend expires the cookie, which clears the browser. When they haven't interacted with the application for 30 minutes, what happens? And then what happens when the user first interacts with the application, where we saw the flapping, the back and forth. So here's this case, and I apologize. I think hopefully this is like this image is clear enough for you to see in the presentation. So here's the simultaneous request bug that we saw before. So you can see this is a logout with simultaneous requests. So there's this first request that completes after the logout request. So it doesn't know that the ID should have been logged out, but the logout request clears the browsing session ID here. And then since Fastly now only resets the expiry, only the expiry has been reset. So the cleared ID and regeneration will happen in the next login. That way this is how we were finally able to fix the logout bug, where not every request has to extend the ID cookie. Every request just extends the expiry cookie to have it expire within 30 minutes, and then the logout clear actually took. So that's the logout case. Here's the expired simultaneous case, where Fastly is incrementing the ID by one, and it's doing the same logic twice. So it doesn't matter, it arrives at the same end ID, so we don't see like the toggling back and forth here. And then for the new simultaneous request, we still have this bug. I mean, we still have, if you're first on the site, especially the mobile application, there's like a ton of really ton of requests, more so than our web application. So we do see some toggling back and forth between browsing session IDs, but eventually when all those requests slow down, we only have one browsing session ID associated with the majority of the user's activity. So that's kind of a known behavior that I wasn't able to resolve for this, but I was able to ensure that every logged in user has a unique, that there's no browsing session ID that's shared between logged in users. So has a unique set of browsing session IDs, which was kind of one of the main purposes of this project in the first place. So that's the flapping bug. I really enjoyed thinking about solving it. It was a fun project to work on, and I rarely say this, but being constrained for time and having to come up with something quick and good enough, in this case, I like that pressure. I thought I was satisfied with what we came up with. So yeah, that's it. That's it for the the flapping bug. Any questions?